we are discussing about two types of structural equation modeling. Okay, so primarily we have two broad categories. One is SEM and another is PLS SEM. So PLS SEM is useful for developing or proposing theories. For example, we develop hypothesis and tested the hypothesis. So based on this hypothesis, the next studies, the studies afterwards, they will use our hypothesis to propose theories. You know how the theories has been developed in the past. For example, TPB, so theory of planned behavior, is a kind of theory in behavioral study, psychology. So they have proposed the theory based on previous, hypothesis, previous tested hypothesis, many hypotheses, means attitudes and behavior, for example. So previously, many studies, they tested attitudes and behavior, and they found a positive relation between attitudes and behavior. So based on this, Mr. Eisen, who is the proponent of or developer of theories, TPB, he concluded or proposed that there is a positive relation between attitudes and behavior. So there is the advantage of developing, proposing a hypothesis and testing hypothesis using PLS SEM. So primary objective of PLS SEM is to develop theories in exploratory research. Okay, next. So the justifications of using PLS SEM. Why should we use PLS SEM, right? Okay, however, for application and prediction, when the phenomena under research is relatively new or changing, or when the theoretical model or measures are not well formed. So meaning, we have developed our framework. Okay, maybe we have taken few variables from previous studies or theories, and I have contributed a new variable in the model. Okay, so we actually have a mix type of variables. We adapted and developed kind of such a scenario. Okay, in that scenario, it is highly suggested that PLS approach is more suitable. In addition, Chin, he states that there are other instances beyond initial exploratory stages that PLS is well suited. In addition, Chin states that there are other instances beyond the initial exploratory stages that PLS is well suited. Okay, Chin also suggested that other instances also. For example, sometimes if my objective is to test a model, but I have access to limited samples. Okay, limited samples. I cannot have more samples. In that case, CB-SEM is very difficult to apply. Traditionally CB-SEM, they demand for more samples in order to make your data fit with the metrics or indices. But in case of PLS SEM, it requires less sample size. So that is one of the advantages actually. Okay, so in that case, it is very justifiable to use PLS SEM. Okay, so researchers' argument for choosing PLS SEM as a statistical means for testing structural equation modeling are as follows. There are many justification you can provide. For example, PLS SEM makes fewer demand regarding sample size, as I mentioned. Okay, it does not require a normal distributed input data. Regression requires your data should be normally distributed. This is one of the basic assumption of regression. So in order to produce a reliable result, your data must be normal. Okay, so in PLS, their assumption is non-parametric. Okay, their assumption is non-parametric, means they don't keep any assumption actually about the distribution of the data. They don't bother about the distribution of the data. Okay, so whatever the distribution size, it may be normally distributed or abnormally distributed, for example. So they do bootstrapping. Okay, PLS, they execute bootstrapping method. So bootstrap, it make the data normal. Okay, and after that it calculate the significant indices. So it's not a problem for PLS to use the non-normal data and produce a reliable result. So if you are very concerned about the distribution of your data, then you should use PLS SEM because it doesn't bother about the distribution. Okay, next, PLS can be applied to complex structural equation models with a large number of constructs. Okay, complex structural equation models. Sometimes we have very complex model, right? So many variables, many moderators, many mediators. Seems very complex. So in complex model, you hardly find the CBSM, I mean the AMOS, for example, that it will give you a reliable. I mean, AMOS, you cannot pass the basic test, basic fit indices of AMOS with this complex structural model. So in that case, even if your model is very complex, you can use PLS SEM and it will give you a better result. So PLS is able to handle both reflective and formative constructs. Okay, both reflective and formative constructs. So what is reflective and what is formative construct? Okay, we will discuss about this later, but before that we get the idea that if model have reflective and formative constructs, so it is better to use PLS SEM. Okay, then PLS is especially useful for prediction. PLS is especially useful for prediction. PLS, the objective of PLS is to see the predictive power of independent variables. So these are the justifications. Okay. Next, measurement model versus structural model. So in structural equation modeling, when we draw the structure, we will see some model like this, and we should know about the basics of the model. For example, we have a measurement model, sometimes call it outer model, or sometimes call it as exogenous latent variables. Okay, and here we have at the bottom structural model or inner models. Okay, so now which part is related to structural model and which part is related to measurement model, right? So from the diagram we see the dotted box, right? we have x1, x2, x3. We have 3 items. So these are basically the indicator variables, 3 items and 1 variable. Okay, here y1 is a kind of variable. So unobserved variable, latent variable. Okay, it's called latent variable, meaning y doesn't have any score. Okay, for example, attitudes. Okay, think about y is a kind of attitudes. Okay, but attitudes doesn't have any score because we don't ask what is your attitudes. Okay, rather we ask 3 questions related to attitudes. So each question is represented by actually x1, x2, and x3. So x1, okay, it does have a score. Okay, so x2 has a score, x3 has a score, right? So for example, x1 might have 1 to 5 scale, right? Agree to strongly agree to strongly disagree. If you see, if you imagine this scale, then x1 may have 4, for example. X2 may have 5, for example. Okay, so they have the scores. Okay, but y1 it doesn't have any score. Okay, so when we think about items and variables, right here, items and variables. So this part is related to measurement model or outer model. You see, it is outside, right? It is outside. So that's why it's sometimes called outer model or exogenous variable. Okay, exogenous, why? Because this arrow starts from here to there. It originates from here and pointed to there. Okay, y3. Okay, these are items, and there is also arrow we see. Okay, when the item or when the arrow comes from item, we call it kind of a reflective model. Okay, we are coming to this discussion in later also, reflective and formative. But right now we want to understand what is measurement model and what is structural model. Okay, so we see we have a measurement model here and also there. We have measurement model in exogenous, we have measurement model in endogenous latent variables. Okay, and now come to the structural model. So it's called inner model. So from the figure we see, yes, the box inside that confine only the variables, right? Only the variables y1 to y3, y2, and y4. So the relationship between variables only, not item to variable, right? The relationship between variables only is related to structural model. Okay, that's the understanding, right? So again, the relationship between item to variable is part of measurement model. Okay, and relationship between variable to variable, okay, is called structural model. Okay, next, formative and reflective. Okay, okay, let's talk about formative and reflective. Before coming to the conceptual understanding, we want to see by image, I mean by the structural drawing, which is formative and which is reflective. Okay, so this one at the left side, it's called formative model, and the right is called reflective. So how do you know it is formative? By see the just the figure or the drawing. For example, you see the arrow starts from item, okay, originates from item and hit to the variable, right? So just by indicating the arrow, we understand it is formative. Okay, it is formative construct. Okay, the arrow coming from items to variables. Okay, this is formatting. Okay, here we see the arrow in reverse order. So here arrow is coming from variable and it is pointed to the items. Okay, so that's the indicator that we understand it is reflective. Okay, so most of the cases you will see reflective models. In most of the cases you will see reflective models. Okay, and only you will find very rare models that uses formative models. Okay, now here the values between items and variable in formative model is called weights, and this value is called loadings. And in the inner model, the values between variable and variable, we have a value here, okay, is called path coefficient. Okay, so again we have a measurement model here. This is formative measurement model. We have a reflective measurement model at the right side. We have also inner model with only two variables. Okay, this is called structural model. So this is another conceptual, another understanding. Okay, now coming to more detail about reflective and formative. When we should use reflective model and when we should use formative model. Okay, so reflective, first reflective. For example, we want to study the customer satisfaction of a hotel. Okay, customer satisfaction of a hotel. So I can design the scale using reflective format, as well as I can design it using formative scale. Okay, first reflective. If you see the item, first one, I appreciate this hotel. I am looking forward to staying in this hotel. I recommend this hotel to others. So the item coming from variable to, items. Sorry, the arrow coming from variable to items. So this is one indication that it is reflective. So now we want to understand deeply why there is reflective and why there is formative. So looking deeply in the items, in the questions, we see there is a similarities between questions. For example, I appreciate this hotel. I looking forward to staying in the hotel. I recommend this hotel to others. There are much similarities between questions or between items. Now, if I delete one item, okay, so the rest of the items may be enough to measure this variable. Okay, if I delete one item, for example, I delete this one, last one, I recommend this hotel to others, I delete this one. But again, using only two items, I appreciate this hotel, I am looking forward in staying in this hotel. Using only two items, I am still in a position to measure the satisfaction level. Okay, so that's the understanding that items are similar, means you will get a similar score here also. Okay, and if you delete one item, it will not have any adverse effect on the scale, entire scale, entire variable. Okay, so there is no question of validity even if I delete one item. Okay, that's the understanding of reflective. Now coming to formative. So the service is good. The same hotel, same kind of abstract idea, variable. We want to study the customer satisfaction level, okay, of our hotel. So we asking here 3 different questions. The service is good, the personnel is friendly, the rooms are clean. We want to see whether respondents respond very positively about these 3 aspects of our hotel. If we see this kind of situation where each of the item, I mean each question actually representing an important aspect of the hotel. For example, we talk about the service, and this one talk about our personnel, okay, staff, and this one talk about our cleanliness, I mean the rooms, okay. So each one is very important. Now, if you see, this is one characteristics. Each one is very important. Second characteristics, you will find that these are not similar. We talk about service, we talk about personnel, okay, we talk about rooms. So these are not much related like the previous one, okay, much related. So meaning there is a chance you will have, you know, high low score here, okay. You will find the score are not similar. Maybe you will find this one is very high score and this one is very low score. For example, you will find that this one is very low score. Personnel is friendly, and your software suggests that you should delete this item because this score, you know, found very low. Now, if you delete the item, now think about the validity of the scale. Okay, you are talking about personnel of the restaurant, I mean the hotel. So a personnel of the hotel. So you actually ignoring an important aspect of the hotel. So that's why there is a concern that, okay, maybe these the next 2 questions, I mean the rest 2 questions, the service and the room, are not enough to measure the satisfaction level. Okay, so if you have in such a scenario, then you should think about that your model should be formative. So in formative model, you may have a high low score, but it doesn't suggest for deleting items. Okay, that's the advantage. You need not to delete items in this model, but here you may delete one item, but the rest of the item is enough to measure your scale. So that's the question, there's the understanding between reflective and formative. Now, before your question, I know you have many questions. Before raising your questions, I want to say that this is not very simple to identify your model, whether it's being reflective or formative. It's a kind of critical decision. Okay, so there are many studies. One study came in 2014, maybe. They have identified that even in the most prominent journals, like Journal of Marketing, for example, in Journal of Marketing, they have used reflective model, whereas these models were supposed to be formative. So means the authors, like those who have publications in A-star journal, like Journal of Marketing, double star. So they have done these mistakes. So you and me, we are doing the mistakes, and there is a chance we can publish in Journal of Marketing because they have done the similar mistake like we do. So you should not be very pessimistic, even if in the past you have done wrong about this model. So is bit complex to identify which one is formative and which one is reflective. It depends sometimes on the experience of the researchers. They can easily identify, okay, by observing the items, questions, and sometimes the loadings, okay. Then they will judge that, okay, I guess my item should be designed formatively. Do you have any question so far? Okay, প্রশ্ন বাংলায় করেন, অসুবিধা নেই।
তাহলে আমি একটা কোশ্চেন করতে যাচ্ছিলাম।
জি জি।
আচ্ছা স্যার, তাহলে ট্যাম মডেল যদি আমি ধরি, ট্যাম মডেলকে দিয়ে কি স্যার আমি ফরমেটিভ এবং রিফ্লেক্টিভ দুটো ফরমেটিভ কি আমি করতে পারবো? মানে আমি আর একটু ক্লিয়ার হতে চাচ্ছিলাম যে আমি কখন ফরমেটিভে যাব, কখন রিফ্লেক্টিভে যাব। এটা আমার মানে আমার কাজের মানে বা আমার কনটেক্সটের বা আমার মডেলের কোন পার্সপেক্টিভ থেকে আমি এটা বুঝতে পারবো যে আমাকে কোন মেথডে যেতে হবে, কোন একটা স্পেসিফিক মডেল দিয়ে যদি আপনি বলতেন।
আচ্ছা, ওকে, থ্যাংক ইউ। So the question raised here is that when should we use formative model and when should we use reflective model? How do you understand? So as I said, it bit confusing always, but we have some guidelines, we have some principles. For example, if we see that my loadings, okay, are inconsistent. First, one is very high, another is very low, okay, high low. My loadings are high and low, and software suggests that loadings below 0.5 should be deleted, for example, okay, or the literature suggests loadings below 0.50 should be deleted. And when I come to delete, then I see this question is very important, okay, it's very important. It is actually measuring an important aspect of my variable. Then I should think about retaining this item. So, but reflectively, it is very difficult to retain this item. So now you should think about designing formatively, okay. So there's the first understanding that you can understand that you can design reflective model formatively. Then go for justification, okay. You will justify that, okay, the item is very important, all the items, so it should be designed formatively, not reflectively. Is it clear?
Yes sir.
Okay, thank you. Any more
বাট
questions?
এটার ইউজটা তো মনে হয় একটু কম না স্যার? আমরা রিফ্লেকশনেই তো বেশিরভাগ কাজ দেখে আসছি, মানে ইনফরমেটিভ।
Yes, yes, as I said before, that the use of reflective model is very common, but use of formative model is very rare because it needs more justifications. That's why we rarely see formative models. Okay, come to more. I have not so many, slides. Okay, observed variables measured directly. Sometimes we have in PLS we use models, variables that measure directly. As I said, we have age, we have income. This can be measured directly, okay, like this model. they use observed variables only, like teacher-student ratio, exam score. So these all have numerical score. But attitudes, you don't have direct score, right? Okay, now latent variables, unobservable, measured indirectly. So we have many variables that cannot be measured directly. So we call them latent variables. Okay, so here we see a complexity, for example, complexity. So you cannot measure complexity by directly. You don't expect the respondents will say a numerical number in response to question like what is the level of complexity. Okay, so instead we ask many questions to understand complexity. Okay, to understand about the variable complexity, many questions. Like here we are asking 5 questions to understand the variable complexity. Okay, so we call this kind of variables as latent variables. Okay, so together with the items and the variable, we call it construct. Okay, construct, item, variable in together. Sometimes we call it construct. Okay. Next, steps in structural equation modeling. So here I have given a reference book by Joseph Hare. So I copied this steps from his book. So it's very simple. Stage 1, we have to specify the structural model. I mean inner model first. Okay, for example, we see attitudes and behavior. So this is very simple model. Attitudes influence behavior. So we have a very simple model. This is our structural model. Okay, imagine we have only 2 variables. One is attitudes and another is behavior. Okay, so we have specified or identified our model. Next, stage 2, specifying the measurement model. So at this stage, we identify how do we measure the variables, right? Identified at the first stage. So we have attitudes and we have behavior. So now how do we measure? So we have identified the items or the questions to study or to measure attitudes and behavior. So this is talking about specifying the measurement model. So stage 3, data collection and estimation. Okay, stage 4, PLS path model estimation. We don't see the effect. Normally we draw the model and algorithm. I mean the software, they design the algorithm or they develop the algorithm accordingly. Okay, we have assessing PLS result of the reflective measurement model. So if our model is reflective, we have to assess the measurement model first, reflective measurement. If we have formative measurement model, then we have assess the result of the formative measurement model. Then we have structural model. Okay, and after that we have interpretation of results and drawing conclusions. So these are the very generic steps. So what we need at stage 5 and 6, I mean, if we add evaluation the measurement model, if it is reflective, what do we need to do? And if it is formative, what should we do, right? So then in structural model, what should we do? Okay, these are the steps. Okay, structural model procedure. Okay, I hope you all has installed the software as well as you have activated the license. I have given you the license. Okay, any questions so far?
আচ্ছা আমার একটা কোশ্চেন আছে
Okay.
যে স্টেপস এর স্লাইডটাতে একটা কোশ্চেন আছে
এখানে
হ্যাঁ আগেরটাতে আগের স্লাইডটাতে স্টেপস হ্যাঁ স্টেপস
yes.
আমরা জি আমরা এখানে দেখলাম যে আমাদের ডাটা কালেকশনটা করতে হচ্ছে স্ট্রাকচারাল মডেল এবং মেজারমেন্ট মডেল স্পেসিফাই করার পরে
জি জি
কিন্তু এর আগের ডিসকাশনে আমরা জেনেছি যে আমাদের মেজারমেন্ট মডেলের ক্ষেত্রে আমরা কি ফরমেটিভ করব না রিফ্লেক্টিভ মডেল আমাদের করব এটা ডিপেন্ড করছে আমাদের লোডিংসটা দেখার মাধ্যমে আমরা ডিটারমিন করতে পারবো তো লোডিংস তো আমরা ডিটারমিন করব আমরা ডাটা ইনপুট দেওয়ার পরে অ্যানালিসিসের পর সেক্ষেত্রে আমাদের ডাটা কালেকশনটা তো মানে স্টেজ 3 তে আসে কিভাবে আমরা কি আগে ডাটা কালেকশন করে লোডিং বের করার পরে আমরা মেজারমেন্ট মডেলটা স্পেসিফাই করতে হবে না নাকি না বুঝতেছি না
okay nice observation. I think, thank you. So the question is, sometimes we are not certain what would be my measurement model. Okay, so in that case, is it should we collect data before specifying measurement model, or we should collect data after specifying the measurement model? As I said, this is a generic steps. Okay, generic steps means generally the steps are like this. So if we see that after collecting data, my reflective model is not working properly, so then we think about designing the model formatively. So means I am reforming my measurement model after collecting data. So the steps 2 should come afterwards, right after 3. So that's the the concern, the question. So again, we have a preliminary model. Okay, we have a preliminary model. We specify already whether model is reflective or formative. Okay, then after that we go for collecting data. So sometimes we do reform. Okay, we redesign. So it's kind of exceptional case. Okay, so these steps is generally mean for general cases. Okay, for general cases. I hope you get the point, right? Imagine you have a very simple model and you have collected data which is observed variable. Measured directly. Okay. So we have teacher student ratio, teacher salary, household income, percentage of single family, and we have dependent variable here. It's called exam score. So we have a very simple model like this. So in that case, we want to test the model. Okay, we want to test the model in PLS. So means PLS can handle both observed variable as well as unobserved variable. Later in file CCA, we have a model like this. Inshallah, we'll try this one tomorrow. But today we want to test this model, very simple model, to see whether PLS can produce a result based on observed variables. Okay, observed variables means we have only one item. Okay, we measure this directly. Means when we talk about teacher student ratio, we get a numerical score. So when we ask our respondents that, oh, what is your exam score, we get a numerical score directly. Okay, it's not like attitudes, it's not like satisfaction, it's not like complexities, right? So this is different variables, right? We call it observed variables. Okay, so now if we go back to our data folder, okay, data folder, the file name is given here, exam score. This is the file name, exam score. Okay, exam score. We see a folder, exam score. Okay. I guess you don't see my Excel folder, right? You do not see.
Don't see.
Okay, okay.
Please
So
share
now,
the screen.
Exam score. Okay, I guess.
Yes.
So here in the folder, I mean in the data file, we have a 2, 3, 4, 5. Okay, 5. I mean the variables. So and each variable has score. Okay, so now we want to test this model. Okay, it's called exam score. So if we open the PLS software, okay. Okay, now I open the PLS software. I guess you see my screen, right? SmartPLS. Do you see my software, SmartPLS?
Yes, sir.
Still not seen.
Okay. So now this is the, I mean the appearance or the interface, we call it. Technically, they call it interface. This is the default interface of the software. So we have here a new project. Okay, we have to create a new project. Click this one and name a project like this. I have exam score. Score, okay, 5, for example. Exam score 5. So then we have to import the data. Okay, import the data. Double click. Then import. Okay, so it gives you the descriptive statistics very quickly. So here you see you have minimum, maximum, standard deviation. Okay, mean, median, minimum, maximum. So these are basic I mean information about your data. Okay, so you know, as part of the analysis process, before starting the analysis, you need to check whether the data is okay. Okay, whether the data is okay. So we need to screen the data to make it error-free before, I mean, importing this data into SmartPLS software. So in Excel, we have some, calculations, or we have some process by which we can identify whether data have problems or not. Inshallah, tomorrow we'll talk about this. Okay, the data screening process tomorrow. Okay, right now we assume that our data is okay. So if the data is okay, I mean data has not much problem, so then we go to this icon, exam score. Okay, double click the icon. Then we have to draw the exercise. I mean, what I have shown you already. This is in the exercise slide. Teacher student ratio. Okay. So first, ratio, teacher student ratio. Drag and drop. Okay, drag and drop. Okay. Teacher student ratio, then teacher salary, then household income, then salary, then household income, then percentage of single family. Okay. Income, then exam score. Okay. So these are the variables. So the red marks indicate the variable is not, okay, or the model is not okay to run right now. So we have problems. The red marks indicates that we have problems. So it shows that this latent variable is not connected to other latent variables, right? So at first, before connecting, we want to rename the variable. Right click and rename. So this one in the model is called teacher student ratio. Okay, teacher student ratio. Okay, we renamed it. Okay, then we have teacher salary. Okay, teacher salary. Then we have percentage of single family. Then we have household income. Okay, and here it's called exam score. Exam score. Okay. So now we want to move the item to the right direction. Right click, align indicators right. Okay, if you want to align this one, if you see it is disorganized, you can select all together, right click and align indicators left. Sorry, this one. This one, align selected items, element left. Okay, you see, the aligned is very nicely, but not nicely. You have selected only the, we should select only the variables. Okay. Okay, now it's very straight, nice. Then, okay, we have to connect independent variable on dependent variable. So there is a connector at the top. Connect teacher student ratio on exam score, teacher salary on exam score. Single click, just single click, single click. Okay, now the color has changed. It turned into a green, I mean the blue color. It means it is now okay for analysis. So then you have to deselect, I mean unselect this one by clicking the select button. This one, there's arrow. Okay, so now it is gone, the connector is gone. So now the model is ready to run. So before testing the model, we want to understand what is the model about. So in this model, we want to see whether these variables, these 4 variables, has effect on exam score. Okay, has effect on exam score. This is the objective we want to see. Or we can say, what are the factors? What are the factors determining exam score? Or what are the factors affecting exam score? So we can define our objectives differently. Okay. So based on the literature review, for example, we have identified there are 4 factors like teacher students ratio, teacher salary, percentage of single family, okay, household income. So these are the kind of variable we have identified. Okay, so we want to see the relationship. So now this relationship, what is our hypothesis about this relationship? Teacher student ratio, if the ratio is high, what would be the effect? Is it positive effect or negative effect? Okay, if the salary is high, will it have a positive effect or negative effect? So if so, let's say this household income, right? So is high, then what would be the effect on exam score? So there's sort of hypothesis we have to define or developed before testing the model. So imagine that we have developed a hypothesis for this relationship. Okay, for our understanding, it is easy to understand. Okay, teacher salary and exam score. So our hypothesis is, if the teacher salary is high, the student exam score will be high. So teacher salary has a positive effect on exam score. Okay, higher salary indicates higher exam score. So that's the hypothesis we develop particularly for this relationship. So similarly, we have hypothesis for rest of the relationships. So now, how do you develop hypothesis? From the literature review or from theoretical justifications, from previous studies, from theories, or sometimes if we don't find theories or previous studies, we develop based on logic, based on rationality, and we justify using our rationality. Okay, so we try to convince our readers that that hypothesis I have developed is logical. Okay, so that's the idea. Okay, now we want to test whether our hypotheses are true, are supported or not supported. Okay, based on the data. So before collecting data, we actually develop our hypothesis. Before collecting the data, we are developing our hypothesis. Okay, so now we have collected data. We want to test whether my hypothesis is supported or not, and we want to see how much is the effect of these three variables on exam score. Okay, so now we have here different buttons. We have calculate. We can do it from here, or we can do it from there also. Calculate, PLS algorithm. Okay, so now at the beginning you see the interface like this. Okay, algorithm interface দেখা যাচ্ছে কিনা?
দেখা যাচ্ছে।
Okay. Okay, we see the interface like this. So here we have some default settings. Okay, weighting scheme, we have three different methods to identify or to calculate weighting scheme. So we just keep it in default position. Maximum iterations, we also keep it in default. And what does it mean about these three settings? It is given here. Okay, and if you want to learn more about this thing, you can go to their website. They have many more resources. Okay, this is very useful software. So they have designed everything accordingly. No problem, you can learn more about those things. Okay, they have given a stop criteria 7. Okay, we keep it as it is. So we just mentioned few things about the maximum iteration. Okay, so we talk about the algorithm, how the algorithm works. Okay, so it will rerun 300 times. So normally we calculate one time manually, but using software they calculate the same maximum 300 times. The same model maximum 300 times, and they get the best result out of all alternatives. That's the idea. So okay, if you want to know more about this, so they have given many explanations. Okay, we here at the bottom after calculation we have three options: open full report. Okay, or you can close, no problem. Okay, start calculation. So far this is the most easiest software in in PLS SEM. This is the most easiest software so far. So after that, after calculation, so they take us to the report page. Okay, you can see the reports. Okay, if you want to see our model, the reports in our model, you have to switch to the model. Okay, so here we have seen some figure 1. Okay, these are the loadings. Since the item is only one, we have only one item. Okay, one variable. So here the loading would be always 1. Okay, no need to report this one. Okay, we talk about our hypothesis first. Now imagine we have developed a positive hypothesis of this relationship teacher salary has a positive effect on exam score. But here we see the path coefficient, we call it path coefficient. Okay, the value here is called path coefficient. So what does it mean actually? Path coefficient is basically it indicates the relationship between teacher salary and exam score, or you can say this is kind of the slope. I mean, a change in 1 unit in teacher salary result in how much change in the exam score. So there's the change. Okay, 1 unit change in teacher salary result in this kind of change in exam score. So that's the actual interpretation. Okay, I mean mathematically. But in our cases, in social sciences, most of the cases we don't interpret like this. Okay, we don't interpret this figure like this. We interpret that the relationship is weak, or there is a strong effect, weak effect. So we normally used to interpret like this. So now we see the I mean not so, I mean the value is not so high. So how do you know the value is not high? Because it can be maximum 1. Okay, the path coefficient normally it would be between plus minus 1 normally, typically, but some cases it can exceed plus 1 or minus 1. In that cases we have to think about the data. So data might have severe problems. Maybe there is more standard deviations. Okay, standard deviation is very high, or there are many missing values, for example. So it means it has severe problems. So it shows an abnormal value here. So typically, normally, ideally, you will see the value is between plus minus 1. So if the value is very close to plus 1, means it has a very strong effect. Very strong effect. So if it is close to 0, no, I mean a very low effect. If it is 0, means no effect. Okay, that's the understanding. So we can show you the relative, I mean the line. Okay, you can switch highlight path of, use relative values. Right, you see, by watching only the line you can understand the effect, the degree of effect, right? Absolute, it is relative. Okay, which one looks good, you can switch, no problem. So okay, right now this one, so it means household income, it has the highest effect on exams, right? A second, this one, and third, this one. But teacher salary, no, very low effect. Okay, now after watching this one, next question comes to mind, that whether these effects are significant or not. So testing significance, it comes next. So by which we can actually make a decision on our hypothesis, whether we are accepting, we are, I mean, our hypothesis is being supported or not supported. Okay, traditionally we sometimes we call rejecting hypothesis, accepting hypothesis, but statistically it is not wise to use this kind of terminology, because we cannot accept or reject hypothesis, because it depends on our data. right? Our data doesn't fit with the previous hypothesis. So maybe the problem is with my data, not with the hypothesis. So we are not rejecting hypothesis. Rather, we can say that I did not find sufficient information to support the hypothesis. Okay, that's the very polite or a gentle interpretation about the hypothesis. Okay, now here we want to see whether these values or the relationship are significant or not. So now,
sir, can I have a question?
oh, sure.
Whether the negative path coefficients indicate that there is a negative relationship or
Yes.
negative impact?
Yeah, my data suggests that the relationship here is negative. So I found a negative relation. Even though I have developed the hypothesis, teacher salary, higher salary will have positive effect on exam score. So, but I see there is a negative value here. Okay, your question.
So my question was, the negative result of path coefficients, is it indicate that there is a negative relationship between teacher salary or exam score?
Okay, so the question is whether it shows the relation is negative or not, right? Because it shows the negative
sign.
Right, negative sign.
Yes.
So right. So sometimes we actually by seeing only the minus figure, we draw conclusion that the relationship is negative. Okay, so before drawing the final conclusion, we have to test the significance. If the relationship is significant, okay, this one is significant, then we draw the conclusion, yes, the relationship is negative. But if the relationship found non-significant or insignificant, so we will not interpret the negative sign. Rather, we will simply say there is no relationship or there is no effect. So we are not actually interpreting negative. Or sometimes someone may wrongly interpret it as the relationship is negative, but there is no significant effect. Okay, they say like this: the relationship is not significant, but we found a negative result. You understand? So yes, this interpretation is wrong. Once you conclude the relationship is not significant, so you simply ignore the symbol or the sign here. Okay, you will say there is no relation. Okay, now in our case, we see there is a negative here. Now we want to see whether this relationship is significant or not. Okay, so to see or to calculate the significance, we have to use bootstrapping method. Okay, remember we said finding the significance is depend on the normally distributed data. If the data is normally distributed, then it gives a reliable information about significance. If it is not a normal data, so its result would be very biased, and that's the assumption of regression. Okay, now we haven't tested whether our data is normally distributed or abnormally distributed, right? Or we call it statistically skewed. Okay, so we do not bother about the distribution of the data. Means we don't have any assumption, or we don't want to keep assumption about the data because it is non-parametric study. So we have to make the data normal by default. And to do this, we are using bootstrapping procedure. Okay, bootstrapping. So just click this one. It will take you here a subsamples 500. Okay. Subsample means we have more than 200 cases. So out of 200 cases, they actually make 500 subsamples. Okay, minimum. So ideally, it should be 5,000. Ideally, it should be 5,000. They say for initial assessment, one may use a smaller number of bootstrap samples. For example, 500. For the final result preparation, however, one should use a large number of bootstrap subsamples, 5,000. So you see, for example, you haven't finalized your result. You just want to see the relationship of the initial observation. So in that case, it is recommended, okay, you can use less than 5,000. But when you are taking the final result, that you are putting it into your thesis and or in your publications, papers, then it is highly suggested you should change it. Okay, put another 0. Okay, so but putting another 0, it will I mean take much time to execute the command. That's the disadvantage. Okay, if you keep more numbers here. So that's the idea. Okay, so finally you will use minimum 5,000, but right now we are using 500. Okay, so what is it? What they do actually? They actually create subsamples. Subsamples are created randomly drawn with replacement from the original data. Why? To make the data normal. Okay. Okay. Then okay. Basic bootstrapping, complete bootstrapping. Okay, we keep it basic, and complete means they give more information. But right now we keep it basic, no problem. It's a default setting. Confidence interval, a percentile, bootstrap, okay, bias corrected. Okay, no problem. We keep it default. Test type. We have discussion on this. Okay, one tail or two tail. So that's the confusion sometimes we have. So if my hypothesis, so this one depends on the design of the hypothesis. If I design one directional hypothesis, I should select one tail. Okay, one directional means what? For example, I said that higher salary of the teacher will have a positive effect on the student exam score. So positive, one directional means positive effect on exam score, one directional hypothesis. So in that case, I should select one tail. Okay, in other case, the same hypothesis can be designed in other ways. For example, we can say that there is a significant effect of teacher salary on exam score. Significant effect. So significant effect, it doesn't indicate is positive or negative particularly. Rather, it indicates both ways. It may be positive, may be negatively significant. May be positively significant or may be negatively significant, right? So in that case, if the direction is in two ways, that in that case we'll select two-tailed test. But in our case, we assume that this hypothesis designed in a one directional way, that either positive or either negative. Okay, one directional. For example, teacher salary has positive effect on exam score. So we will select one thing. Okay, there's the understanding. Significance level, it is 95% confidence level, right? We understand this one. Our confidence level is 95%. So in that case, we keep it 0.05. It is our significance level. So we keep it default. Start calculation. Okay. Okay. Now we see one interesting observation here. Teacher salary and exam score. We talk about our this one. Okay, now it is changed to path coefficient at t value. Okay, so we can change, right? We can change path coefficient and p values here. You see, we can change the t values. Now it shows the t values in our model. Now it shows the path coefficient. Okay, so we talked about this one previously. We see the path coefficient was 0.016. So now we wanted, at that time we wanted to see whether this relationship is significant. So we now get the significance values. Okay. Okay, what is the significance value? Primarily based on p values. Okay, primarily based on p values. Okay, if the p value is less than 0.05, okay, 0.05. You see, this is less than 0.05. This is also less than 0.05, but this one is more than 0.05, right? And that's why it shows red marks. Means it is not significant. This relationship is not significant. But here it is also less than 0.05. Last one. So it is significant. Okay, come to another statistical approach or the technique by which we can also identify whether it is significant or not. It's called t statistics, t values. Okay, t values. Okay, by t value we see that, okay, ascending or descending order. Okay, so it is 8 point something, right? And this one is less than 1. So what is the the criteria or the standard value, or we can say the reference value or cutoff value for t statistics to identify it is significant or not? If it is one tail, okay, if it is one tail, the t value should be more than 1.64, more than 1.64. Okay, I will provide you, I have already provided other papers. Inshallah, tomorrow we'll see those papers by which we can, we cannot remember, we need not to remember those cutoff values. Rather, I will refer it to the papers, okay, by which you can just follow the paper and you can interpret by yourself. So right now, if the t value is more than 1.64, so it indicates significant. So this value, you see, it is less than 1.64. So it shows also not significant. So by p value and t value, okay, we can understand whether it is significant or not. So teacher salary exam score, we have not found a relationship. So we should not interpret the negative result, okay, of this value. Rather, we simply state that, okay, there is no effect. Okay, there is no significant effect. That's it. Okay, this is how we can make a decision. For example, in our case, we have developed a positive hypothesis, but we found the relationship is not significant. So decision is hypothesis is not supported. So that's the decision. Hypothesis is not supported. Okay. So this is all about for today's discussion. Hopefully, we will discuss another hands-on, the next, the model tomorrow. And we have also moderator and mediator model also coming in future. Okay. So, okay. So far, any question about this?
I have a question. Sir, two-tailed যদি আরেকটা যদি এক্সাম্পল যদি বলতেন।
Two-tail. আচ্ছা, আমার মনে হয় আমরা আগামী কালকে ওয়ান টেল টু টেল নিয়ে আরো ডিটেইল ডিসকাশন করব ইনশাআল্লাহ। হ্যাঁ,
ঠিক আছে,
সমস্যা হবে না, এটা ক্লিয়ার হয়ে যাবে। ঠিক আছে, আর আজকে
I have a question.
Okay.
Sir, as we see that our p-value is less than 0.01, so can we report the result by 1% significant level instead of 5% significant level?
Not necessarily. Okay, because we have already taken a standard 95% significant. Okay, so here if the value is less than 0.05, so we simply say that relationship is significant. And if it is the t value also more than 1.64, then we conclude that the relationship is significant. So this is how we'll interpret.